Hi everyone, Assalamualaikum. In this video, we are going to continue with example 3 under formation of differential equations. Find the differential equation given the general solution y equals to a cos 2x plus b sin 2x where a and b are arbitrary constants. Right, from the given question y equals to a cos 2x plus b sin 2x, we have constants a and b, right? Since there are two arbitrary constants, the required differential equation must be of order 2. So, you need to differentiate exactly 2 times, right? So, we find y prime, okay? When we differentiate a cos 2x, since we multiply by constant here, so we still have constant a in front. Then we differentiate cos 2x, we get negative sin 2x, right? After that, we differentiate 2x, so we get 2 here, right? And then, when we differentiate b sin 2x, in this term, it multiplied by constant b. So we still put constant b here. And then, when we differentiate sin 2x, we have positive cos 2x. Then we differentiate 2x, so we get 2 here, right? After that, we find y double prime. We differentiate from y single prime, right? Since there are multiplication with constant negatives to a, so we still have constant negatives to a in front. Then we differentiate sin 2x, we get positive cos 2x. Then we differentiate 2x, so we get 2. 2 times negative 2a, so we get negative 4a, right? And then we have constant 2b times cos 2x, so we still put 2b in front, okay? Then we differentiate cos 2x. We get negative sin 2x. After that, we differentiate 2x, so we get 2. And then, 2 times negative 2b, so we get negative 4b, right? Right, then we need to think how to eliminate constants a and b, right? First, we name y as equation 1. And then y prime as equation 2 and y double prime as equation 3. Okay, now look at equation 1 and equation 3. Okay, equation 1 we have cos x with constant a. And equation 3 we also have cos 2x with constant a. Okay, and then from b sin 2x here in equation 1, it's similar to equation 3 sin 2x, and then we have constant for b here, okay? But for y prime, besides sin 2x, we get constant a, okay? So it's not similar, okay? But from equation 1 and equation 3, it looks similar, right? So we can eliminate using equation 1 and equation 3, right? So from equation 1, okay, we have single a, okay, beside cos 2x. And from equation 3, we have negative 4a, okay, beside cos 2x. And from equation 1, we have b beside sin x. From equation 3, we have negative 4b beside sin 2x, right? So, we can multiply equation 1 by 4, okay? Right, so from here, when we multiply equation 1 by 4, so we get 4y and then equals to 4a cos 2x and then plus 4b sin 2x, okay? Then we can name as equation 1a, okay? Equation 1a actually comes from equation 1. Okay, but equation 1a after we multiply equation 1 by 4, right? Right, after that, we can add equation 3 and equation 1a. Okay, right, so from here, we have equation 3 from left hand side, we have y double prime. And equation 1a on the left hand side, we have 4y. So we add, okay? So we get y double prime plus 4y. So we can write here, okay? And after that, negative 4a cos 2x and then plus 4a cos 2x, okay? We get 0, okay? And then negative 4b sine 2x and then plus 4b sine 2x. Okay, we also get 0. Okay, so right hand side equals to 0. Alright. From here, we success eliminate constants a and b. Okay. So in this case, we done find the differential equation. Alright. So this is the differential equation. Okay. This is our final answer. Alright. Got it? We just eliminate using equation 1 and equation 3. Okay, because equation 1 and equation 3 look similar. But before we eliminate, we need to multiply equation 1 by 4 first, so that we can simplify all the constants. Yeah, we can eliminate all the constants, right? Now we look at example 4. Given y equals to 2 sin x plus a cos x, where a is an arbitrary constant, form the corresponding differential equation. Alright, from the given question, y equals to 2 sin x plus a cos x. From here, we have one constant, which is a, right? Since there are one arbitrary constant, the required differential equation must be of order 1. So, you need to differentiate one time only, right? So, from y equals to 2 sin x plus a cos x, now we find y prime, okay? So, we have constant 2 here, so we still have constant 2, and we differentiate sin x equals to cos x, okay? And then, we have constant a here, and then we differentiate cos x, it equals to negative sin x. That's why we get negative a sin x, right? We just differentiate one time only because we only have one arbitrary constant, right? Right, then we need to think how to eliminate constant a here, right? Right, so let's say we name y as equation 1 and we name y prime as equation 2, right? From 2 here, we write a as a subject, okay? How to write a as a subject? First, we move minus a sin x to left hand side. And at the same time, we move positive y prime to right hand side. So we get positive a sin x equals to 2 cos x and then minus y prime, right? And to write a as a subject, we need to divide each term by sin x. Okay, so from here, after we dividing each term by sin x, we get this, right? Then we can simplify and after that we get this. Okay, how we get a equals to 2 cot x minus y prime cos x. Okay, from here, sin x over sin x equals to a. Okay, we simplify sin x from numerator and sin x in denominator. So we only have a here. Alright, and then cos x over sin x equals to cot x. Right, and then over sin x equals to cosec x from reciprocal function. Alright. After that, we can name as equation 2a because equation 2a here come from equation 2 here. So we name as equation 2a. Okay, because equation 2a and equation 2 from the same equation. Right? And then we can substitute equation 2a into equation 1 because now our goal is to eliminate constant a, right? So from here, after we substitute equation 2a into equation 1, so we get this, okay? How we get this, okay? From here, a equals to 2 cot x minus y prime cosec x. We substitute into equation 1 here, into a here. So we get y, okay, equals to 2 sin x plus cos x. We can put cos x in front, okay, and then times a. We replace a by 2 cot x minus y prime cosec x, right? Right after that, we can expand cos x in the function in bracket, okay? So we get this, y equals to 2 sin x plus 2 cos x cot x and then minus y prime cos x cosec x, right? Right after that, we can simplify, okay? We have y equals to 2 sin x plus 2 cos x cot x. We don't need to change cot x equals to cos x over sin x because we cannot simplify with cos x here. Okay, but for cosec here, we can write 1 over sin x because we can simplify cos x over sin x equals to cot x here. Okay, so we get y equals to 2 sin x plus 2 cos x cot x minus y prime cos x over sin x equals to cot x, right? So from here, there is no more arbitrary constant a, okay? And until here, we write this equation in terms of differential equation, right? This is our final answer. We just differentiate one time only because we only have one arbitrary constant. Okay, if we have two arbitrary constants, let's say a and b, so we need to differentiate 2 times. If we have 3 arbitrary constants, let's say a, b, and c, so we need to differentiate 3 times. Okay? In this case, the given arbitrary constant is 1 only. So that's why we just differentiate 1 time only. Okay? But after that, we need to think how to eliminate constant a here, this arbitrary constant here. So that's why we write a as a subject and then we substitute into equation 1 here. And after that, we success eliminate constant a. Right? So this is the final answer. Eh? Coming up next, more examples for formation of differential equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.